Alright, so this is my third time recording. Can't get this thing to work. So, my name's Megan. This is my micro teaching lesson on cladistics. Me and my partner Pam chose natural selection and adaptations for our unit plan project. We decided it would be 60-minute lessons and in the subject area of life science for 6th graders. So here we go. Before I move forward, this is my second lesson for the unit plan project. I just found it easier to make a video on the second one rather than the first. So here we go. So my learning standard is Middle School Life Science 4-2, applying scientific ideas to construct an explanation for the anatomical similarities and differences among modern organisms and between modern and fossil organisms to infer evolutionary relationships. So this is evidence of common ancestry and diversity. So the disciplinary core idea is anatomical similarities and differences between various organisms living today and between them and organisms in the fossil record, enable the construction of evolutionary history and the inference of lines of evolutionary descent. So I would put this up on the board for students to look at. It's the evolution of video game consoles. To try to hook them into the lesson, I would let them know that this is a cladogram. And let me bring this down. I would ask them, did the Xbox One evolve from the GameCube, or do they merely share a common ancestor? So they wouldn't actually know the answer to this yet, but I'm hoping that they would figure out the answer by the end of this lesson. Alright, so instructional activity number 1, I decided to do a KWL chart. So for 2 to 3 minutes, I'd have students independently write in column 1 what they already know about evolutionary relationships in cladograms. And then for another 2 to 3 minutes, once they had completed that, I'd have them independently write in column 2 what they would like to know about evolutionary relationships and cladograms. So for instructional activity number 2, we would discuss how cladograms work. So I found a YouTube video that explains this pretty well, and to keep students intently listening during the video, I would have them fill this out, fill in the blanks while they were watching. So I will play that video now.
It's an image or diagram that shows us an evolutionary relationship between different organisms. So here is a cladogram. This cladogram shows salmon, salamander, lizards, hamsters, and chimpanzees. At the top of a cladogram, you will always have the names of the organisms. Along the side of a cladogram, you will usually have different characteristics, and these characteristics are what separate the various organisms from one another. So for example, all the way down here is the characteristic vertebrae. What this tells me is that every organism from this point on has a spine. As we move up the cladogram in this direction, we get more and more exclusive. This means that the higher we are, the more traits the organisms have to share to be placed there. Let's take a look. We started with vertebrae. When we look at the next characteristic, lungs, we exclude salmon. Salmon do not have lungs, they have gills, and so they are excluded from all the groups from here forward. We can continue this way and look at the next characteristic. Who has claws or nails? Well, all the organisms above this point, so only the lizard, hamster, and chimpanzee, but not the salamander or the salmon. Now, the whole purpose of placing organisms in a cladogram is that it allows us to trace evolutionary relationships. The points where the lines connect represent a common ancestor. So if we look at any particular point, like right here, this point represents the common ancestor. of all organisms after this point. So this organism right here is the common ancestor of lizards, hamsters, and chimpanzees. In other words, long ago there lived an organism who gave rise to lizards, hamsters, and you will often see these common ancestors labeled and have questions like who is the common ancestor of lizards and chimpanzees? And by following the lines, you can confidently answer C. Super important to understand is that what this tells you is that lizards and chimpanzees share that C common ancestor. Chimpanzees and hamsters, for that matter, did not evolve from lizards. They merely share a common ancestor way back in time. So cladograms tell us which organisms evolve from common ancestors. Another thing that cladograms can tell us is how closely related organisms are. Let's look at the chimpanzee. If we were to ask which of these organisms is most closely related to the chimpanzee, or which of these have the most recent common ancestors, we would have to say that it is the hamster. And the reason is that they converge at a closer point than any of these other organisms. If we look at this primate cladogram, we can then explain that humans and chimpanzees share a tailless common ancestor right here, and that we are less closely related to the rhesus monkey since the downward pointing nosed ancestor we share is way down here. In quick review, a cladogram is a diagram that shows evolutionary relationships, and the way it works is that it arranges the organisms across the top and gives you their evolutionary lineage. It also shows you which organisms are most closely related by illustrating the common ancestors between them.
So during the video, I would be following along with students and pausing when necessary so that they can fill out the questions, or fill out the blanks rather. So then we move on to instructional activity number 3. We work on how to build a cladogram. So as a class, we work together to build cladograms on one cladogram on the board. I would demonstrate how to do it to students while they take notes and fill out on their sheet how to do it. I would provide students with all of this on a sheet of paper during the lesson. I would ask for volunteers from students who maybe thought they knew the answer or they wanted to try it out even if they weren't sure. So basically we'd fill out the table here and we'd apply what we fill out in the table here to what is in the diagram here. So basically we are going to put a check in the boxes where things apply. So for wings, we'd have a check here and we'd have a check here, but the rest wouldn't because they don't have wings. So for tail, this one wouldn't have a check, but this one, this one, this one, and this one would have a check. So that's how we would figure out what to put in the Venn diagram. So we'd have to use a step-by-step process to build on that knowledge. So you can't, complete this part without this part and this part. So what you basically do is you draw another square on the inside, and you just kind of put each thing in order. So all of them have 4 limbs. So once you have the checks in the boxes, you would find out which is the next lowest number. And then that's what would go in the next box, and you would write the numbers in. And you'd keep going until you got down to the last thing. And then you would begin to build the cladogram by putting the one organism up here that has all of the characteristics. and the organism down here that only has one characteristic. So this would build up like it showed in the video. So instructional activity number 4, students would be working with a partner. In pairs of just 2, students will fill in this table the same way that we had done as a class. And then students will create their own Venn diagram using this table. And then they'll create a cladogram using the Venn diagram and the table. So after students had completed this with their partner, they would independently answer these 2 questions over here as a summative assessment on what they've learned. So the questions are, according to your cladogram, which 2 species are more closely related, humans and snakes or humans and lizards? How do you know? So they would use the work they did with their partner to answer the questions, but they would have to understand what they had done with their partner to be able to answer the question correctly. And then according to your cladogram, what species are humans most closely related to, and how do you know? So then we'd move to instructional activity number 4, which is the exit ticket. This is how we'd close off the lesson. So I would have students answer these 2 questions, but we would also go to the KWL chart that we started in the beginning of the lesson, and we'd answer the last question, the learning portion. So not only would I have students answer these 2 questions, what was the most surprising thing you learned today, and why was it surprising, but they would also explain what they had learned. So that's basically my whole micro-teaching video. That is lesson 2 out of the unit plan project. Thank you for watching.